Hello grade 7s. Today we're going to look at subtracting mixed numbers with unlike denominators. So for example, 3 and 3/8 minus 1 and 1/2, we have unlike denominators. We've got an 8 with this mixed number and a 2 with this mixed number. So to start with, we're going to use fraction strips to come up with a solution. And so in this case, we've got 3 wholes and then 3/8 shaded, so there's our first mixed number, and then we've also got a whole one and then a half of one for the 1 1/2 mixed number. Now to subtract 3 and 3/8 and 1 1/2, you need to use parts that are the same size. You can't subtract one large piece from 3 small pieces. It just doesn't work. The sizes are different reference points, so we need to make sure that we're talking about the same size pieces so that we subtract the right amount. So in this case, 1/2, if we break it into eighths, we can then say that, well, 1/2 is equal to 4/8. And so that's what we can do using fraction strips. Now, the other problem is that we cannot subtract 4 little guys from 3 little guys, because we only have 3. So we can subtract 3, that's fine, but then we've got that 4th one that we can't subtract. So we need to do some manipulation here. And what we're going to do is we're going to say, okay, well, 1 whole is the same as 8/8. So we can turn our 1 into 8/8, and so that's 1 whole. 8 divided by 8 is equal to 1. So instead of having 3 and 3/8, which was our first mixed number, we're going to take one of those wholes and we're going to convert it into eighths. So instead of 3, we're going to drop that down to 2 wholes, and then with 8/8, we're going to add that to the 3/8, and we already know that when you have a common denominator with an 8, 8/8 plus 3/8 gives you 11/8. So this looks a little weird. We've got a 2 as a whole number and then 11/8. So we've got a mixed number combined with an improper fraction. The value is correct, it's just not a proper format, but we can work with this and then clean up the formatting when we're done. So let's take 1 whole fraction strip, and like I said, we can convert that into 8/8. So that's basically a visual showing this calculation right here, or this equivalency. Now, if you subtract 1 whole fraction strip from the 2, which is what we had, 2 and 11/8. So let's show that. 2 and 8, 9, 10, 11/8, minusing 1, and it was 1/2 originally, but we converted that to 4/8, so 1 and 4/8. So now we can take 2 wholes, subtract 1, and you're left with 1 whole. And then we've got now 11/8, and if you take 4 of those away, that leaves you with 7. So our final answer in this case is 1 whole and 7/8. So 1 and 7/8 as shown here. Now, there are other methods that we can use to solve these equations. So let's have a look at using a subtraction statement and improper fractions. This is probably going to be the most common way to go about doing this. So we can use a common denominator, and we've already talked about how we broke that whole into eighths so that they were all the same piece size. We're going to use 8 again here as our common denominator. Now, we know that if we've got an 8 and a 2, let's just practice this. We've got an 8 and we've got a 2. Let's write out our common multiples. Well, we start with 8, then we go to 16, 24, 32. That's getting pretty big now, and in this case is really overkill, but just to practice the process. So 2, 4, 6, 8, 10, 12, 14, 16, 18, etc. And we should draw etc. on both of those. So our lowest common multiple in both lists, hopefully you can see, is our 8. Now, there are other common multiples. For instance, 16 is in both lists. And in fact, every number in this list of the multiples of 8 will actually work, because 2 is a factor of 8. So all of these numbers will eventually show up in the list of 2's. So you can use any multiple of 8 to actually do this, but the lowest common multiple, which is going to give us the smallest numbers to work with, that's going to be our 8. So we've done that, we've double checked, we're going to use 8 as our common denominator. Now, in order to do that, and it kind of shows it here, we've got 3 3/8, that's already using an 1/8, which is great, it's less work to deal with, but we've got this 1 1/2 that we need to convert to something over 8. And if you look at this, to go from 2 to 8, we're multiplying by 4. If we multiply the bottom by 8, then we have to multiply the top by 8. So 1 times 4 becomes 4. And so the equivalent of 1/2 using eighths is 4 over 8. And we already saw that using the fraction strips, but just to go over it one more time just to see how this works is important. So instead of subtracting 1 1/2, we can now subtract 1 4/8. Don't forget, the whole number, it doesn't change when you're doing equivalent fractions, trying to find a common denominator. The whole number is just that, it's whole. So we don't have to worry about altering it. It's the fraction part that we could have an equivalent fraction for. So we just change the half into 4 over 8. So we have a new equation, 3 3/8 minus 1 4/8. And now we continue. Now, same problem as we saw before. We can't subtract 4 over 8 from 3 over 8. So in that case, we're going to actually convert everything here into an improper fraction. And then you'll see it becomes a lot easier. So there's a couple techniques you can use. Like we did previously, we can change each whole into 8 over 8. So if we're changing 3 3/8 into an improper fraction, we've got 3 wholes. So there's 1 over 8 over 8, a second 8 over 8, 3 8 over 8s, plus then the fraction section of 3 over 8. You can do that. It's a common denominator across the board of 8, so that's going to be your bottom denominator. And then 8 plus 8 is 16, plus 8 again is 24, plus 3 gives you 27. So now we're dealing with a fraction of 27 over 8. Now, the faster way to do this is to take the 8, multiply it by 3, so we're doing a times, and then we're doing an add, and we're going in this direction. So 8 times 3 is 24, plus 3 is 27. So 27 over 8. So this just shows it here. 3 times 8 plus 3. That gives you the 27 over 8. So we've got a new fraction here of 27 over 8 that we're using for the first mixed number. And then we'll convert the other one here as well. 1 4/8. So we're going to say 1 times 8 is 8. And then you add 4 becomes 12. So it's 12 over 8. Or you can say, okay, well, we've got one whole, that's 8 over 8, plus the fraction, so 8 plus 4 is 12, with a common denominator of 8. Either way that you go about it, you end up with 12 over 8 as your second mixed number converted to an improper fraction. So now it gets fairly simple. So here's our two fractions that we originally started with. We've converted them into mixed, or improper fractions, I should say. And we know when subtracting with a common denominator, the denominator stays the same, and then we just subtract the numerators. So 27 minus 12, which is 15 over 8. So that is the final answer, but that is an improper fraction, and it's improper to leave that as the solution you provide. So in this case, you're going to need to convert it back into a mixed number. So to do that, 8 goes into 15 one time, so there's your whole number, and there are 7 remainder. So 8 goes into 15 once with 7 remainder, and your denominator stays the same. So that is your final answer for the question. 3 3/8 minus 1 1/2, it is equal to 1 7/8. Now, you've got a show you know to do. So please go ahead and do that.